Welcome to my channel and welcome to this tutorial, simple linear regression analysis, that is linear regression model. There are several tools in statistics that are used for various analytical purposes, but the simple linear regression is mostly used to find the relationship between two variables or more, as the case may be. That's just the preamble about this simple linear regression. In this tutorial, we are going to give a example on how to apply simple linear regression to solve some problems. All the parameters that are associated with this simple linear regression will be explained. As you listen, thank you very much. Let's deep dive into this tutorial. Introduction to simple linear regression. The simple linear regression analysis shows the relationship between two or more variables. For this tutorial, I'm going to discuss about the simple linear regression between variable x and y. That is, we have multiple regression that comprises of several explanatory variables with one response variable or dependent variable. But in this tutorial, we are going to explicitly study the simple linear regression, that is, the regression with one response variable or dependent variable and regression with one explanatory variable or independent variable or a predictor. In the subsequent tutorial, I'm going to go deeper more into the multiple regression, that is, the regression that comprises two or more explanatory variables with one response variable. But for this tutorial, we are going to limit our study to the simple linear regression. And also, this simple linear regression comprises some definition which is going to assist us in knowing this simple linear regression better. For example, in the definition of the concept, let variable x be equal to independent, that is, this variable x is also known as independent variable, predictor, or explanatory variable. These are the three names that are associated with variable x: independent variable, predictor, and explanatory variable. Why is it called explanatory variable? If an incident or an occurrence occurs to the independent variable or the predictor, it's going to have direct effect on the effect on the dependent or response variable. And let variable y be equal to dependent variable or response variable. In this tutorial, I'm going to talk about the linear regression of variable y on variable x. This is why it is called a simple linear regression. Firstly, like I said, in this tutorial, we want to define some concept. In the simple linear regression, we have some concept to define, in which we already defined the two variables x and y. And again, we are going to define slope. These are the components of the simple linear regression. That is, the slope is represented as beta 1, and the formula for the slope is n summation xy minus summation x summation y. Since we are dealing with y on x, we are regressing y on x, all over n summation x square minus open bracket summation x close bracket all square. Or we can apply this formula as well. These two formulas, they give us the same answer. This is a formula that we can use to calculate the slope, and this is another formula that we can use to calculate the slope. And these two formulas, we are going to experiment them. Maybe they are going to give us the same result. And for this second formula, we have summation xy minus n open bracket S bar, close bracket, and open another bracket Y bar. So compared to this one, we have summation X, summation Y. But here we have X bar, Y bar. All we have summation S square minus N, open bracket, S bar, all square. These are the two formulas that we are going to apply to solve the simple linear regression. Furthermore, still in the definition of the concept of the simple linear regression, we are to calculate the intercept. That is, this is the formula for the intercept. That is, when the variable x is at constant 0 or held constant, this is what we are going to, how we are going to calculate it. That is, beta naught is equal to y bar minus beta 1 x bar. That is, the beta 1 is the slope, as you can see in the previous slide. The beta 1 is the slope, while the beta naught is the intercept. And after calculating both this slope and the intercept, it is then that we can write this simple linear regression equation model. This is the simple linear regression equation model. Y is equal to beta naught plus beta 1 x. This is the formula for the simple linear regression model, and we are going to show how to apply it in the exercise in the next slide. Note, there are other types of regression analysis. We have simple linear regression, which we are treating now. We have multiple linear regression, which we are going to do in the next in our next tutorial. And this multiple linear regression comprises of several explanatory variable or predictor with one response variable or dependent variable. And this logistic regression is a special regression analysis in which the response variable is in binary form, and it's a special regression that is mostly used for predictive purposes. Although the two can be used for both simple and linear regression, their major function is for predictive purposes. But in this logistic regression, the only difference is that the response variable, which is y, which is dependent variable, is in binary form. For example, people have two options in admitting to the hospital. Either they are admitted or they are discharged from the hospital. Those are the two ways. Or in examination, in an examination, student can either pass or fail. Those are the two options. If you have that such kind of response variable, we are going to apply the logistic regression. And mostly the logistic explain its outcome in probabilistic model or by using the odd ratio for comparison purposes. So these two, multiple regression and this logistic regression, they are outside the scope of this tutorial. We are going to explicitly explain the simple linear regression. Furthermore, just I'll be defining some concepts of this simple linear regression. So we have this exercise that we are going to use to enhance our understanding. And the exercise is, after investigation, it has been discovered that the demand says, which is demand or says, is the response variable y for a vehicle in a city depends on the number of family residing in that city. The number of family is the explanatory variable, while the sales or demand for vehicle is the response variable. Now we are given this data, that is city. We have city A, B, C, D, and E. That is, we have 5 cities that want to study the rate at which each family are buying car. Now, the family in city A, or in all the cities, they are mentioned in tens of thousands. That is, this 70 is 70,000, 75,000, and 80,000 up to the 90,000. Then the sales of the vehicle is in thousand. So and so on and so forth like that. So whenever we are interpreting, we are going to interpret with with this value giving us 1,000 or in 10,000. Now, in this exercise, we have to calculate the slope and the intercept, which we are already shown the formula and how to calculate it in the previous tutorial. So in question one, we have to calculate the slope and the intercept. Then number two, we have to calculate the regression equation and include the value of the coefficient, that is beta naught and beta 1. Then interpret. The next question 3 is to interpret the slope and the intercept. Then 4, we have to predict the sales if the number of family residing in the city is X is equal to 50,000, that is in a city where the number of family residing are 50,000. So we want to determine the number of vehicles that will be sold. Then finally, we have to calculate the coefficient of the determination, which is R square, and we have to interpret the result. These are the tabular form of the data given here. So we already placed it in the table because we need to calculate some parameters here. That is, we have to calculate the xy. We have to calculate xy, x square, and y square. As well, we have to calculate the mean of x bar, and we have to calculate this is the sample size, which is 5. 1, 2, 3, 4, 5. So in doing so, xy, we have to 70 times 25.2, giving us 1764, up to 90 times 35.4. It's going to give us 3186, and so on and so forth. Then summing everything together is going to give us 10,849, and summing all this y together is going to give us 141.7, and summing all the x together, which is number of family, is going to give us 375,000. So, and also we have to find the x square, that is the square of this 70 square is giving us 4,900. Then 75 square is going to give us 5,625, and 60 square is going to give us 3,600. 90 square is going to give us 8,100, and y square is going to give us this value. These are the total for y square, 14115.49, and these are the total for x square, 28625, and so on. And this is the value for the mean of the number of family in the city, that is the summation x, which is this value 375 all over 5, which is the n. As you can see here, it gave us 375 all over 5, it gave us 75. And also the mean of y, the number of vehicles sold, is summation y all over n, which is 141.7 all over 5, giving us 28.35. Furthermore, now we have to calculate the initial question stated that we have to calculate the slope. This is the slope and the intercept. And firstly, we have to calculate the slope. Beta 1, n summation xy minus summation x summation y all over n summation x square minus summation open bracket summation x close bracket all square. So all these value that we have in this table, we are going to insert it into this formula. We are going to this formula. Then this is our answer for the beta 1. Then, like I said earlier on, we want to compare these two formula. The beta 1 is 0.4430, and this is second formula to calculate the slope. Summation xy minus n into bracket s bar close bracket into y bar all over summation s square minus n into s bar all square. Then, like we already known the value for our mean, which is s bar y bar, which are these values, and 20.34 respectively for y bar. So we are going to insert it here. We are going to insert all this value here. So, and the answer is give us 0.4430. As you can see, These two formula depend on individual choice now. You can use either this formula, the first one, or you use this formula. We are still going to arrive at the same answer. Now we have to calculate the intercept, that is the beta naught. Already we have known our beta 1. Now we want to calculate our beta naught, which is the intercept. And the formula for the intercept is y bar minus beta 1 s bar. And we already known our y bar to be 20.3434, and we already know our beta 1 to be 0.4430, and we know our s bar to be 75. So we are going to replace all this value with this all these parameter or variables with with their value. The y bar is 20.34 minus bracket open, beta 1 is 0.4430, close bracket and open bracket again into s bar, which is 75, and the other give us minus 4.8550. That is our value for the self, and our value for the slope is 0.4430, and this one is already negative, the intercept. Now we have to write the regression equation, and the regression equation goes as follows: y is equal to beta naught plus beta 1 x, and we already known our beta naught to be minus 4.8850, and our beta 1 to be 0.430, and this set we are going to place it there because it's very, very useful for the prediction of the variable. Now we are told to interpret our slope. This is the slope, 0.4430. So, and we know that this is number of car vehicle sold, and it's in thousand. So when in the interpretation, we are going to say for a unit change in the number of family residing in the city, the vehicle sales will increase by 0.443 or 0.4430 vehicles. And how do we get this 4,000? Because we are measuring our because our vehicle sales is in thousand. So we use 1,000 to multiply this value. That's how we got this 4430. And the interpretation of the intercept. Let me explain further for better clarity. This slope is 0.4430. This is the value. So since we are reporting in thousand, we are going to use 1,000 to multiply it to give us this value. Then, like I said in the beginning of this tutorial, that whenever there's any changes in the explanatory variable, the response variable will react to that change. That's why we have, for a unit change in the number of family residing in the city, the number of family is the x, then the vehicle sales will increase. That is, this response variable has reacted to the change in the explanatory variable, which is the family residing in that city. The vehicle sales, which is the response variable or dependent variable, will increase by 0.443. Or, since we are reporting 1,000, we are going to use 1,000 to multiply 0.443, give us 4,430 vehicles. That's how to interpret it. Then for this interpretation of the intercept, if the family residing in the city is held constant means that if no family in the city bought the vehicle will drop by this, we drop by minus 4.8850, then multiply it by 10,000, the vehicle sale will drop by 48,850 vehicles. That is, if the family residing in the city is held constant, that is, no family in the city is buying the car, the vehicle sale will have a constant reduction of 48,850 vehicles, which is not too heavy for the company selling the the vehicle. Invariably, the company will fall down because if they have a constant reduction in their sales of this amount, which means that the company has to be relocated out of the city to another area that is more viable to the business. For consultancy purpose, this is the advice that you're going to give to the stakeholder if such situation occurs, that is, family in the city are buying the car, which means that no car is bought. That means why we have this constant zero. So there's going to be a gradual reduction in the sales of that vehicle by 48,850 vehicle. We have to predict the vehicle sale when the family residing in the city X is equal to 50,000. That is, this is the linear regression equation, and we already put the values here. That is our beta naught minus 4.8850 plus beta 1 is 0.4430x. Now, so this x is here. We don't know it initially, but now we want to make prediction that if the family in a certain city is 50,000, what will be the value? Can we predict the value of vehicle that will be sold? Now, we are going to replay this. I think you can see this Y. We already placed art on it, which means that it's a predictive value. Then we are going to repeat all this value. Minus 4 Y art is equal to, that is predictive Y is equal to minus 4.8850 plus 0.4430 open bracket 50,000. That is the number of family in that city, which we are predicting, are giving us 172,650 vehicles that will be sold if the family in the city is 50,000. Now we are told to again calculate the coefficient of determinant, which is R square. And the essence of this coefficient of determinant is just to know the accuracy or how related the both response variable or the explanatory variable are to each other. That is, what are the percentage or dependent variable that will be explained by the explanatory variable. And this is the formula. This is the formula for the R square, and the coefficient of determinant is R square is equal to beta 1 square times summation S square minus NS bar square all over summation Y square minus NY bar square. Then we already known our beta 1, which is this 0.4430. We are going to put it there. Then our summation S square, we already known it in the table, and minus 5, and our S bar is 75 all square all over summation Y square. We already know it to be 4415.49 minus like as it is here. This our Y square. This is our Y square. This is this value. So we are going to slot it into this formula, into this formula, and our Y bar is 28.34. We already know it. Then times the n. This is the n, which is 5, our sample size. And having gotten it, we already know our numerator to be 98.1245 all over 99.7120, which is equal to 0.9841. Since whenever we are reporting the coefficient of determinant, we have to multiply this value by 100. So, and our value of R square is 0.9841, or 0.9841 times 100, giving us 98.41%. So we are going to interpret this R square here. Then the interpretation of R square, about 98.41% of total variation in the vehicle sales in the city will be explained by the family residing in the city, whereas 1.59 of the vehicle sales were accounted for by an unexplained variation. That is, what this play was telling us that for this dependent variable, 98% of the family, 98.41% of the family bought the vehicle. That is, it explained this the number of vehicles sold. And we have another 1.59 vehicle that was sold as well as against this number of family that contributed to the sales of this vehicle. But that factor was not explained. So that's why we say it accounted for by unexplained variation. Furthermore, let me quickly summarize our tutorial. So going back to the start of this. Now, in this tutorial, we are talking about simple linear regression. So in the simple linear regression, it's just to show the relationship between two or more variables. But for a linear regression, we have simple linear regression, we have one variable and one dependent and one response variable. And we have some definition of concept like x variable, y variable, and beta naught and beta one, and so on. We talk about multiple regression, logistic regression, how they can be applied. And again, we have this exercise. In this exercise, we have this predictive value, and we have this again, beta naught and beta one. We show the two formula that can be used to calculate it. And again, we are told to calculate the intercept. This is the formula to calculate the intercept. And furthermore, we have to write the regression equation, y is equal to beta naught plus beta one x. And this is the interpretation, like I said earlier on, and we have to interpret the slope and as well as the intercept. Also, we have to predict the sales of a vehicle by family. So based on the regression equation, like here, y is equal to minus 4.8850 plus 0.4430x. So this x is the number of family in that city. So these are the number of vehicles that will be sold as a predictive value. Then we have to calculate the coefficient of determinant, that what is percentage of the response variable that we explained by the explanatory variable, and we have 98% of total variation, independent variable, that is number of vehicles sold, explained by the family residing in that city, and we have 1.5 now of unaccounted variable that explain another sales in the vehicle in that city. Thank you very much for watching this tutorial. If you find value in this tutorial, like, share, and subscribe to my channel. Your subscription is very, very much important to me, because the subscription will help the algorithm to move, and it's going to push my cause forward. Thank you very much. Bye.